How big can a wave actually get? Titan seas. This is the largest passenger ship ever built, and right now there is not a single wave in frame worth mentioning. 365 meters of steel sitting on flat water. Now watch what the ocean can put behind it. That wall was measured. Somebody walked a ridge afterwards and wrote the number down. So how big can a wave actually get? You need to know exactly how big that ship is first, because for the next 10 minutes it never leaves the frame, and every wave you are about to see gets measured against it. 365 meters, bow to stern. Longer than the Eiffel Tower, is tall, laid on its side. 20 decks. From the waterline to the top deck rail is roughly 60 meters, which means one deck is about 3 meters of height. Remember that number? 60 meters. Every wave in this video gets counted in decks. The water climbs from here. By the end of this video, that ship reads as a toy. We start with a wave that broke the odds rather than the record. 120 to 220. November 2020. A sensor buoy off Vancouver Island sits in an ordinary winter sea. Waves around 6 meters. Rough, but nothing a working vessel would blink at. Then it records one wave nearly 3 times the height of everything around it. 17.6 meters, crest to trough, measured by the buoy's own motion sensor. The number is not what made it famous. Sea states get quoted as significant wave height, the average of the tallest third of the waves in a record. The world record for that is 19 meters, logged by a buoy between Iceland and Scotland in 2013. Ucluelet was nowhere near that, it just refused to behave. Researchers put the odds at once in 1,300 years, so how big is that really? Just under 6 decks. The crest breaks level with the lifeboats and no higher, the most freakish wave ever recorded, and the ship barely notices it. So what happens when the ocean stops being freakish and just gets angry? New Year's Day, 1995. The Draupner gas platform, 100 miles off southern Norway, sitting in a 12-meter sea. Bolted under the platform was a laser pointing straight down, firing twice a second. At 3 that afternoon, it caught a wave of 25.6 meters, trough to crest. Before that afternoon, rogue waves were sailors' stories. Draupner turned them into data. But nobody could explain it. It took 24 years. In 2019, a team rebuilt the wave in an Edinburgh tank, and the only way it worked was by crossing 2 wave systems at about 120 degrees. 2 storms, feeding the same water from different angles. 8.5 decks, high enough to put green water through the bridge windows of most cargo ships afloat. Hold that shape in your head, because the wall you saw at the start was 20 times taller than this. That is the tallest wave ever measured by a fixed instrument. The tallest with a human riding it is bigger. Nazaré. Just offshore, a submarine canyon runs almost to the beach, 5 kilometers deep at its head, funneling Atlantic swell into one peak. On the 29th of October, 2020, Sebastian Steudtner rode a face measured at 26.21 meters. Getting that number took 2 years. Analysts used the length of Steudtner's own lower leg as the ruler, rebuilt the wave in 3D, and back-calculated the camera angles. In 2024, he rode a bigger one, 28.57 meters, measured by drone, still awaiting ratification. Treated as unconfirmed. 9 decks. Now find the human being in this frame. He is there, that speck. But the open ocean does not need a canyon. February 2000. The research ship Discovery, working the Rockall Trough west of Scotland, gets caught in a storm that should not have produced what it did. Westerlies had been blowing across the Atlantic for 2 days, and the front driving them moved at almost exactly the speed of the waves it made, feeding them for hours. And the instrument logging all of this was bolted to a ship that was taking every hit. Discovery's recorder logged individual waves up to 29.1 meters, crest to trough. Across 12 hours, it counted 23 separate waves above 20 meters. The crew spent that night wondering whether they would see morning. 10 decks, half the ship's height above the waterline, and it is still the largest wave ever recorded by a scientific instrument in the open ocean, which means every wind wave bigger than this one was measured by eye, including one almost exactly as long as our ship. 5:10 to 6:20. February 1933. The USS Ramapo, a 146-meter Navy oiler, running Manila to San Diego through a storm stretching from Asia to the American East Coast. 7 days of wind over open water with nothing to break it up. The waves ran from directly astern, long and smooth. The one condition where a crew can stand still long enough to measure something. A watch officer lined up an oncoming crest with the crow's nest and the horizon behind it and solved the triangle from a rolling deck. The answer came out at 34 meters. Flag this one. It is a geometric estimate from a moving platform rather than an instrument reading, and it has been argued over for 90 years without ever being beaten or confirmed. The officers also timed it. Period of 14.8 seconds. Wavelength, 342 meters. 11 decks tall. And crest to crest, that wave was 342 meters long, which is our ship, bow to stern, with 9 meters to spare. That is roughly the ceiling for wind, and the wall you saw at the start is still 15 times taller than this. Everything past this point is a different animal. Everything so far was built by wind. Air dragging across water for hundreds of miles for days. Those waves travel in trains, they have a wavelength, and they obey a rule we will get to shortly. Displacement waves get thrown. Something solid falls into water, and the water has to go somewhere in a hurry. June 2017, Western Greenland. A mountainside above Karrat Fjord let go. Up to 58 million cubic meters of rock hit the water at once. Survey teams read the height off the shoreline the way you read a flood mark. Stripped rock below the line, untouched ground above. Over 90 meters close to the slide, 32 kilometers down the fjord, it had decayed to 1.5 meters, and it still flattened half the village of Nugatsiak, 90 meters, which is 30 decks. The entire ship above the waterline, and then half of it again stacked on top. And by landslide standards, that was a small one, 720 to 830. October 1963, northern Italy. 270 million cubic meters of Montauk dropped into the Vajont reservoir in 45 seconds. The wave cleared a 261-meter dam by more than 100 meters. The arch held. Everything below it did not, which is still not the record. July 1958. An earthquake on the Fairweather Fault drops 30 million cubic meters of rock into the head of Lituya Bay, Alaska. From 900 meters up, Howard Ulrich and his 7-year-old son were anchored in the bay on a fishing boat. They were carried over the tree line on the crest and set back down. Both survived. Surveyors came back and measured the trim line on the spur ridge opposite the slide. 524 meters. Be precise about that number. Runup is the height water was driven up a slope, not the height of a wave standing in open water. The wave that ran down the bay was a fraction of it. Stand our ship on its end, and it reaches 365 meters. The water went 159 meters higher. It cleared the tip of the Empire State Building, so why does the number stop there? Why not a kilometer? For wind waves, the ceiling is geometry, and it was worked out in 1893. A wave breaks when its height reaches about 1/7 of its wavelength. Past that, the crest narrows to the sharpest angle water can hold, the top outruns the wave itself, and the whole thing falls over. So the ceiling depends on wavelength. 1/7 of Ramapo's 342 meters is 49, and real seas break well before the limit. That is why the open ocean tops out in the 30s and not the hundreds. Wind waves are not limited by wind. They are limited by their own weight. A rock slide ignores that rule. It punches a hole in the ocean and the ocean fills it back in. There is no wavelength to break against. The 2022 global model of the Chicxulub impact puts the rim wave at 1.5 kilometers. It collapsed almost immediately, and by the time it reached distant coastlines, it was running at around 10 meters. Even that one obeyed the same physics on the way down. 9:30 to 10. The ocean can throw up a wall of water taller than anything we have ever built, and it can do it in under a minute with no warning at all. Everything you just watched was measured. Lasers, buoys, hull recorders, survey lines cut into a mountain. None of it is imagined. The ship never changed, only the water did. If you want to know what happens to a vessel that meets one of these, the 90 seconds between the first crest and the last radio call, that video is on screen. Click it.